Welcome to this tutorial. The topic is standard form and ordinary form. Standard form is a scientific notation while ordinary form is the usual form of number we deal with in our daily activities. Now looking at some examples under standard form. Number 1, 60,000 in standard form can be written as 6 multiplied by 10 raised to the power of 4. Now, there's an invisible decimal point here which needs to be counted before the first number, which is 1, 2, 3, 4. Now, the decimal point ends here, which simply means 6 times 10 raised to power 4. Now, question 2, 480 million in standard form can also be written as, now, starting from this angle, I said there's an invisible decimal point that needs to be moved from this edge before the first number, which simply means, let's count. This is 1, 2, 3, 4, 5, 6, 7, 8. Now, which means 4.8 times 10 raised to the power of, this is 1, 2, 3, 4, 5, 6, 7, 8, raised to the power of 8. Example 3. Example 3. Now, example 3 already has a decimal point, which needs to be moved twice. Now, moving this decimal point from this angle is 1, 2. So that means 3.4772 multiplied by 10 raised to power 2, because the decimal point was moved twice. That's why the 10 is raised to power 2. Example 4. Now, example 4, if you look at it, the power will be negative because the first number here is less than 1. So it's going to have a negative power. Now, because this 0 is less than 1, this simply means 8 multiplied by, now let's count it. Let's count the powers. We have 1, 2, 3. So we are moving it thrice. That's 1, 2, 3. So that will give us 8 multiplied by 10 raised to the negative power of 3. Now, the reason why this power is negative is because when the first number is less than 1, it will always give a negative power. Now, let's look at examples under ordinary forms. Like I said, ordinary form is the usual form of number we deal with in our daily activities. The usual form of numbers we deal with in our daily activities. Example 1, 5 multiplied by 10 raised to power 4. 5 multiplied by 10 raised to power 4, which simply means 5 multiplied by, that's 10,000. 10 raised to power 4 is 10,000. 5 multiplied by 10,000, which equals to what? 50,000. 50,000. Example 2. 4.88 times 10 raised to the power of 7. 4.88. That's 4.88 multiplied by 10. Now, the numbers of 0 will be 7. 1, 2, 3, 4, 5, 6, 7, which makes it 10 million. 10 raised to power 7 is 10 million. Now, 10 raised to power 7 means 1, then we have 7 zeros, which is 10 million, multiplied by 4.88. Now, this 4.88 means 2 decimal places, meaning I'm going to cancel out 20 from the 10 million. Now the final answer will now be 488. Now let's count the numbers of 0 left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that makes it 48,800,000. Example 3. Example 3 says 7 multiplied by 10 raised to power of negative 5. 10 raised to power of negative 5. Now, this negative power simply means division, which could be written as 7 divided by 10 raised to power of negative 5 is, that's 1, then 5 zeros, 1, 2, 3, 4, 5, which is also equals to, now, I'm going to count the decimal points from behind into how many places? 1, 2, 3, 4, 5. So now if I'm counting it, it means 1, 2, 3, 4, 5. So that gives us what? Whenever you end, you put a dot and add 0 to it, which gives us 0.12. This is 1, 2, 3, 4, 5. Then the last number, which is what? 7. Example 4. 5.18 multiplied by 10 raised to negative 3. Because the power here is negative, that makes 5.18 to be divided by what? Now, 10 raised to power negative 3 is 1,000. 1,000. Now, the reason why the division sign is showing here is because there's a negative sign, there's a negative power. So now, for me to divide 5.18 divided by 1,000, this simply means I'm going to be moving the decimal point. I'll be counting it backward 3 times. 1, 2, 3. Then add my 0 to it. So that gives us what? 0.00, which is a 30. If you look at it, 1, 2, 3, 1, 2, 3. 1,000 has 3 zeros. Now counting it from behind gives us 0.00518.